Welcome, viewers! We are moving on to Unit 4, which is about basically proving triangles congruent and how to do that. So we're going to start with today what's called the triangle sum property and also applying some congruence. But before we begin, let's first classify our triangles by the sides and also by their angles. So this is just review, but I think it's good to do before we start. So a scalene triangle is a triangle that has no congruent sides. And the way we show that is by putting a different, oh gosh, my pen is white and that's not going to work. How about we try blue? Okay, we put one mark here, maybe two here, and three here, because that lets everybody know, go away, okay, that all the measures of each of those sides are different. Now isosceles, we have to have at least two sides congruent. So there we go. And then the third one, I'll leave blank, but you could put 2 because now that shows that the third side is a different length. When you have an equilateral triangle, equilateral, equal sides, all the sides are congruent. Okay, that's classifying triangles by their sides. Now we're going to classify triangles by their angles. When you have 3 acute interior, inside angles, that's an acute triangle. When you have one right angle, that's a right triangle. And an obtuse triangle has one obtuse angle. An equiangular, equal, angular angles, equal angles. All the interior angles are congruent. So I'm going to put a congruent mark around all those interior angles to show that they're all the same. I'm going to move on to the next vocabulary, which is interior angles and exterior angles. Now, I really shouldn't, this mark, we know, says that all those angles are congruent, but I'm just trying to show you that those are the interior angles. They're not necessarily all the same measure, but they're on the inside. Exterior angles, this might be new to you. If you take any side of any triangle and extend it out, that creates what's called an exterior angle. Okay, so I could create an exterior angle. Let's just take a different color and maybe I'll come over here. There's an exterior angle. It's on the outside, exterior, outside of the triangle. So that leads us into the triangle sum theorem, which is, and this is how it's written in a textbook, and it's good for you to see that, the sum of the measures of the interior angles of a triangle is always, no matter what kind of triangle, 180 degrees. You are going to find that very useful. So the measure of angle A plus the measure of angle B plus the measure of angle C is always 180 degrees. And then the exterior angle theorem says the measure of an exterior angle, and in this case we're talking about angle 1, right there. The measure of an exterior angle of a triangle is equal to the sum of the measures of the two non-adjacent angles. What does that mean? It just means that we've got an adjacent angle with angle 1 here, right? Those two are supplementary because they form a straight line. So those two angles are supplementary. The other two interior angles, if you think about it, all 3 of those interior angles add up to 180. So all 3 of those angles together are 180. And then these 2 angles are 180. So, whoops, erase. So, where's my, okay, yes. Okay, so basically, if this angle is supplementary to the measure of angle 1, then we know that this angle is equal to the measure, the measure of angle 1 is equal to the measure of these two, because angle 1 is supplementary with this angle, and all 3 of those angles add up to 180. So the measure of angle 1 is equal to the measure of angle A plus the measure of angle B. Hope I didn't thoroughly confuse you there. All right, so we'll get to that in just the practice in just a second. Label the exterior angle measures in the diagram. So we're just going to label all the angles we possibly can here, okay? So in this case, we know the sum of all interior angles adds up to 180 degrees, right? So you'll take out your calculator and you do 180 minus 110 minus 40, and what you have left over is 30 degrees. We also know that these two angles are supplementary, which means together they add up to 180 degrees. So if the measure of this angle is 110, and there should be a degree sign there, then the measure of the other angle that's supplementary to that should be 70 degrees. If I was in class and I make a mistake, I'd have one of you guys telling me. I hope I don't make a mistake because no one's here to remind me or to tell me where I mess up. So that one's got to be 140, right? 140 plus 40 makes 180. Okay, these angles in a different color, black, are called, hope you remember, I'm pausing, vertical angles. Vertical angles are congruent. So this angle is 30 degrees. Another way you could look at it, you could do first, and I'm going in whatever order I want. You could have done it differently. Those two angles are supplementary. So if the measure of one angle is 30 degrees, if you do 180 minus 30, you get 150. And then this one has to be 150. But you could have gone 130, 150, 30, 150. It doesn't matter what order you go in. And I think I've done all the angles in the triangle. So we've got the exterior, we've got all the interior, we're good. All right, now we're going to use a third angle, the exterior angle theorem that I was just trying to explain to you. Use the diagram to find the measure of angle DCB. Let's figure out where is that. DCB. That's the angle we need. We know from the exterior angle theorem that the measure of this angle is equal to the sum of the two angles that are not next to it, that are not adjacent. So I can write, this is just one way to figure this out, okay? I can write 3x minus 9, that's an x, equals x plus 73. I'm going to pause. I'm going to have you guys pause it right now, solve that, and get it the next value. All right, so I've solved it. I got the value of x is 41. Now, once we get the value of x is 41, we have to read the problem again and make sure. Sometimes we're done. In this case, we're not. They're asking us to find the measure of angle DCB. There are a couple different ways to do that. You don't have to do it the way I did. But I said, all right, if x is 41 degrees, and I know the measure of this angle here that we're looking for is equal to 73 plus 41, I just took the two numbers and added them together and got 114. Or you could take your 41, because now you have your value for x, and plug it in to 3 times 41, and then subtract 9. You get the same value. We are moving on to some vocabulary that you might have to pause and write down. So congruent figures are all the parts of one figure that are congruent to corresponding parts of another figure. Okay, and the corresponding actual parts are the corresponding sides and the angles. So let's look at an example. So write a congruent statement for the triangles. Identify all pairs of congruent corresponding parts. Now you're going to see questions that say write a congruent statement, and a lot of people kind of have a little freak out when they see that. All that means is this angle is congruent to this angle, or this side is congruent to this side. So for example, when you have two, in your diagram, if you've got two figures and one's rotated, sometimes it's easier to redraw one of them to be facing the same direction as one of the other ones. That way it's easy to identify angle A is congruent to angle F. And corresponding side, side AB is congruent to side, now you have to write FG. And that's not a measure for the side. We're just talking about the name of the side, so we're putting a line over the top of it. But A corresponds to F and B corresponds to G. So if we're going to write AB, we have to write FG. If we had written BA, which would have been perfectly fine, then we would have to write GF. All right, so fill out the rest of that, and then we'll come back and I'll show you the answers. All right, so go ahead and check all your angles and your sides. Make sure you got the same answers that I did. And I didn't explain how they, I didn't explain how they named the two triangles. If you're going to name triangle A, B, C, you're going to start at A, go to B, and up to C. You have to name the other triangle the same direction. F, G, H. It's kind of hard to do that if you don't rotate the two triangles so that they're facing the same direction. So let's go to the next one, example 2. In the diagram, this is important here. QRST is congruent to WXYZ. So I've got a flipped figure, and I'm going to redraw the second one to face the same direction. I'm going to make it just a little bit bigger so I can draw in here comfortably. Okay, so this is QRST, and the next one would be in the same direction, WXYZ. Now I'm just going to copy what's in this diagram, 5x plus 5 degrees, and WX is y minus x, and what else am I missing? Is that it? Okay, so now I am looking at my new triangle and the triangle that they drew. Okay, so I'm not even looking at this one anymore. All right, find the value of x. Okay, so x is here in the measure of this angle inside W. We know that W corresponds to Q. So those two are congruent. So in the solution, they say angle Q is congruent to angle W. All right, well, let's go ahead and set those equal. 5x plus 5 equals 65. Solve for x. We'll do that in just a second. Then they're asking for the value of y. Well, once we find the value of x, we're going to be able to plug it in for x here. And then we'll know y minus x should equal 6. So we could find that value. So go ahead and do that for both of those, and then I'll show you the answers. Okay, take a look at my answers. So I got x is 12 when I subtracted 5 from both sides and then divided both sides by 5. I got x is 12. And now we're going to use that 12 and plug it in for x. Y minus 12 should equal 6. Add 12 to both sides, we get the y value is 18. And I think we've answered both of those questions. Moving on. So do these checkpoints, and then I'll give you the answers. Okay, so here are the answers. I didn't even use the diagrams to do these. F, if you're looking at how they named the two diagrams, F is the first letter, and so is S. So angle F corresponds to angle S, and so on. For the sides, F, G are the first two letters, so are S and T. So FG corresponds to ST. And that's how I did the sides. For finding the value of x, you set 2x minus 7 equal to 103. Solve and you get x is 55. Then they're asking for the measure of angle G. You could, like we did in the last problem, you could substitute in 55 for x, or you could just say, well, angle G is congruent to angle T. So we know that angle T is 103. So the measure of angle G is also 103. All right, last slide. So the third angles theorem is really just common sense. If two angles of one triangle are congruent to two angles of another triangle, then the third angles are also congruent. I'm going to put the symbol for congruent, okay? Because all three of them have to add up to 180. So you'll get a diagram. We've got vertical angles here. So this is 44 degrees, right? Because those are vertical angles. We're told that, I should probably put a different 2 marks there since this has 166. So this angle is also 66. Well, now we've got two triangles that have two angles that are exactly the same, which means that the third angle is going to be the same for both of them. And 66 plus 44 adds up to 110. So that means the missing angle in both of these triangles has to be, what, 70 degrees? And they're asking for the measure of angle V, so you write the measure of angle V equals 70 degrees. Done. Boom!